A leading electric component manufacturer was developing a new enclosure for residential electrical panels or breaker panels. The design team wanted to ensure the electrical panel enclosure was the best design possible because a residential electrical panel was a new product for the company, and it is in a competitive space, and there are numerous regulations related to electrical panels. An analysis was required to ensure all the needs are identified and taken into consideration at the best cost possible. A function tree was developed. One value proposal was to increase the size of the main breaker opening to reduce the stress on the panel enclosure. This could be done during fabrication with an extra die and would replace the die used to create the knockouts, which generates stress during installation of the breakers. This could be done with no change in cost, but would greatly facilitate installation. Other proposals generated a minimum of $3.13 or 5.7% savings on the product. With a market of thousands of units per year, this meant a lot to the company. A major manufacturer hired new staff who were not very experienced with maintaining the equipment used in the fabrication process. The company needed a corporate training program to enhance new employees' knowledge. But before preparing that training material, the department had to determine what knowledge and skills were to be developed. A value design session was held in which the tasks of the maintenance crew were identified. To each task, a skill was attached, and eventually a training program was identified. A service company had a long list of IT projects it wanted to implement, but what could it use as prioritization criteria? It used the value that each project would create within the company based on the functions each project would fulfill. In turn, the functions describe what the company delivers to its clients. Many projects were reorganized, thus eliminating redundancy and overlaps, not previously identified by the project managers. 10 projects remain, but since they added up to 4.8 million euros, but the budget was 3 million, the projects had to be prioritized. They were prioritized based on the value they created for the organization, those in the green circle having the highest priority. A roadmap was then created based on these priorities. The Quebec provincial government is investing in healthcare infrastructure. It is expanding the world-renowned Cardiac Institute of Montreal. The project was estimated at $87 million. A value study was done that identified proposals to save $1.65 million, but the value study also identified other proposals that increased the cost by $1.7 million. Taken together, these proposals presented an increase of $55,000 on a project of over $87 million, but which yielded a very large improvement in value for patients and the province. The project better fulfilled the needs of the users, both personnel and patients, at the same cost. How did these organizations achieve better value in their projects? How did they reach savings in manufacturing? A less costly building, shorter lead times, a better satisfaction of their needs, and a better project portfolio? These projects were all optimized with value analysis. Hi, my name is Lucie Parrot, and I am the president of Value Analysis Canada, Canada's national non-profit organization representing the value community and promoting the best practices in the value methodologies.
Hello, My name is Cédric Berger, founder of Value University, and I will show you the new developments in the value methodology.
Together, we will present how these examples of value improvements were achieved with value analysis.
We will show you what value is, how to create it, measure it, and manage it.
We will also show you the value methodologies can be applied to products, infrastructure, processes, services, and to project portfolio. Today, we will define what value is, what is a function tree, a function cost, measuring value, examples before we conclude. Value can be defined as the relationship or the ratio between the satisfaction of the needs and the cost of resources required to satisfy those needs. In our analysis, we often use the word function to encapsulate how the needs of the client can be satisfied, and resources to encapsulate the cost. Value is thus defined as function over resources. Any resource other than cost can be optimized. It could be weight in the case of an aircraft engine, or it could be area when optimizing a metro station, or even water consumption when optimizing an industrial process, and so on. In the world of finite resources, it is important to optimize the use of them so that the need being satisfied uses only the necessary resources. This is being called eco-value. There are different strategies to improve value. Here are some of them. One strategy is to reduce the cost while maintaining satisfaction of the needs. Another one is to increase the satisfaction of the needs while maintaining the cost. Another strategy to increase value is to reduce the cost a lot while accepting to reduce satisfaction a little bit. A fourth strategy would be to increase the cost a lot by satisfying the needs a lot more. Finally, the best strategy is to increase the satisfaction of the needs while reducing the cost. There are small differences between the different ways to use the methods to fit different contexts. For example, we use the word value engineering when we apply the methodologies to design a new product starting from nothing. We use the word value analysis when we optimize an existing product. We use value management when we use the methodologies within the whole company, either to optimize their processes, their products, their services. As for value design, when we combine concepts of business analysis, value analysis, and design thinking all at once in an agile environment. Before going any further, we must understand the concept of function. So, what is a function? A function defines what the product must do in order to satisfy a need. It's the expression of this need, and it must be formulated in a specific way. The function will be accompanied by an indication of the required performance, and to that we will attach a level and a flexibility. According to European Standard EN 12973, the description of a function shall be clear and brief, with a verb specifying the nature of the action required to satisfy the need, and a noun indicating the element on which an action is exerted. There are many methods that can be used to identify functions. Here are some of them. As mentioned, functions have performance levels associated with them. For example, in our enclosure for electrical panels, there was a function called fit between studs, and its performance criterion was the standard distance between the structural elements. This was measured at 14.5 inches in America, and the flexibility of this was set at F1, very small flexibility. Functions also have levels of abstraction. Some are very abstract, such as ensure safety. Others are less abstract and more tangible, such as connect ground. We can attach them by asking how do we ensure safety by connecting ground, or why do we connect ground to ensure safety. A function tree shows all the functions a product must do by following the how-why logic. For example, here is the function tree of the enclosure. You can see that the mission statement is to safely distribute power in a residence. How does it do that? It's by distributing the power. How does it do that? It's by receiving the conductors, connecting them, and so on. Function costs are important to know. It is much more difficult for a team to assess if the cost makes sense when viewing a simple list of component costs. Viewing a list of function costs gives much more information and enables the team to understand how much it costs to satisfy each need. For example, in this case, the cost associated with the function ensure reliability was close to $30, more than 50% of the cost of the whole product. 68% of ensure reliability was allocated to the function protect components mechanically. Bam! This was startling to the team since they had done the original design without a clear description of what was needed, and of course by looking at the competing products. The team realized that this was a mismatch between the enclosure, once installed, is well protected. The team looked for less costly solutions to reduce the cost of this function. A last thing that must be done is to compare various solutions. With the many proposals that the team can suggest, it is possible to prepare scenarios. Here we compare the value of the various scenarios by placing them on a value graph, where the level of satisfaction of the needs is placed on the y-axis and the cost on the x-axis. This represents the value. Here the blue scenario has the best value and the purple one has the least value. Value is represented by the slope of each dot, the one with the highest slope having the highest value. Okay, but how does this analysis happen? We have developed what we call the value engineering job plan. What is it? How does it work? The job plan and facilitation is as important as the analytical method. The job plan has aspects designed to keep teams on the target and resist political and power influences. It has been standardized throughout the world and consists of a few steps. The first step is setting out the problem. What is the problem? What do we need to do? Why do we need to solve it? Who will participate? Also, what information do we have regarding the present situation? The next step is a function analysis. It consists of 5 sub-steps: identifying the functions using one of the methods or a few, organizing the functions in a function tree, characterizing the performance associated to the functions, prioritizing the functions according to the importance the client will give them, and finally estimating the cost of each function. These steps help understand the current situation and the needs that are fulfilled or not. They are focusing on the now. Notice that the job plan resists looking for solutions up until this point. The next 2 steps involve finding a solution. They are focused on the future. Here we start with creativity or ideation. What solution could we use to accomplish these functions and thus fulfill the needs? A lot of ideas can be generated. The function tree is a very effective tool for idea generation. Once we have a whole bunch of ideas, we need to identify which ones are important to explore a little deeper. Sorting methods can be used by the facilitator to help the team identify the best ideas. Then starts the development phase, where we develop proposals. We call this also the exploration phase. Here, a group of team members will assess if the proposal will work better than the present situation, if it's feasible, if it can be implemented, whether the market will accept that new solution, and how the cost compares to the current solution. Once the value improvement proposals are developed, they can be combined in interesting scenarios that will accomplish the stated mission. The scenarios are presented and their value is measured in order to recommend which one has the most value. The scenario is then implemented by the client.
After this linear model, here is a new model, more agile, allowing more iteration. We have four main loops: problematization, elicitation, ideation, exploration, called PEX cycles. Each step of the classic job plan can be found in the iterative job plan. They are represented by the similar colors.
Teamwork is essential to value engineering. We need to select people that are open-minded and creative. Each individual brings unique knowledge to the table and contributes to the global knowledge of the team regarding the subject under study. Each team member is an integral part of the success of the workshop. The job plan has aspects to keep the knowledge flowing and resist power dynamics. Through the explanation of the VE process, you have seen the results applied to an enclosure for electrical panels. Now let me show you examples in other contexts and with other goals. Let's have the look at the design of a pool house. As mentioned, a function tree shows all the functions that a product must do following the how-why logic. Here is the function tree of a pool house, where the mission statement is said as allowing a more enjoyable and safe life during activities related to pool use. We can see that the first two functions are basic, store related products, and facilitate access to pool activities. They are essential to the pool house buyer. Another function is to ensure safety, which is a constraint function. And the last function would be to embellish the backyard, which is a support function. The cost of the functions has been calculated by distributing the cost of the base case onto each function. We can now add the cost of the functions in each column, and we can now see that the most expensive function is to embellish the backyard. Is that really where the buyer wants to put the money? A markets research found that the middle-class buyer, which was the target client, estimated that the function embellish the backyard had the least importance in the buying process. So why put the most money in that function? Suggestions were made to better balance the costs of the proposals. For example, for storing towels, we could use basket. For isolating persons, we could put a curtain instead of a door. To prevent falls, we should invest in a good skid-free floor. And to provide extra storage space, we have to ask ourselves, do we need to provide that extra space on the side of the pool house? Finally, a better adapted scenario was proposed. Here we can see that scenario 2 has the most value. Here is an example with a process. Analyzing the fabrication process for a liquid sold in 4 different fragrances, it was noted that rinsing the pipes between the preparation tank and the bottling equipment used a lot of water and time. Indeed, the very long lines had to be washed with potable water to ensure there was no contamination between fragrances. One suggestion was to prepare a neutral base in the existing tanks and inject the fragrance close to the bottling line. By having 4 tanks for the 4 fragrances, it is no longer necessary to rinse the entire supply line from the preparation tank. Only a small part needs to be rinsed, each tank having its own supply to the filler. This saved a significant amount of 78,000 liters of water per year and a lot of time. This is truly eco-value. Here is an example in a construction project. The government of Quebec invests millions in its health infrastructure. Lately, it invested in the expansion of the world-renowned Montreal Heart Institute. The goal was to revisit the proposed solution to ensure that all needs are covered at the best possible cost. The issues with this project was that the expansion took place near the existing building. The results of the study: 38 value improvements were proposed, and the project ended up at the same cost, but a better project. For example, let's look at the electrical wires. The planned solution had copper conductors throughout the whole expansion. The proposed solution was to use aluminum alloy conductors for feeders over 100 amp and copper for those under 100 amp. The savings: $300,000. Another example on floors. The planned solution was flexible flooring throughout the project to meet the hospital cleanliness standards. The proposed solution was to use composite vinyl tiles in the offices. The savings: $70,000. A third example was for patient lifts. The planned solution called for 30 rail-mounted patient lifts, one for each bed in the new expansion. The proposed solution was 2 patient lifts only. The people around the table said that that would meet their needs. The savings: $42,000.
Now let's have a look at how value was used to select the best product on the market. How to choose an alarm system. The goal of workshop is to find the system with the most value. The stakes are to respect national and IP communication protocols. The results are that 5 products were found, 3 were studied, 1 was selected, and presented the best value. We created a function tree after collecting the needs from all the stakeholders. This allowed to prepare and send a RFP to 5 potential suppliers of alarm system based on Internet protocol. 2 products were eliminated by management, 3 were studied and compared to many factors: how well they fulfilled the needs, technical feasibility, political acceptability, and their cost. The IP product, the green line, brought the same user satisfaction as the others. But what set it apart was its ease of integration, infrastructure already in place, and it respected the company standard at the lowest cost.
Each of these examples have shown how the value methodology was applied, what the problems were, and how they were solved. The value of the subjects under study was increased by either increasing the satisfaction of the needs or by reducing the cost of the solutions used to satisfy these needs. Many times, both were achieved at the same time, resulting in even more increased value. You have been shown how the value job plan achieves results through these examples. These results can be a clearer understanding of the customer real needs and their relative importance.
Reduced risk, better decision making,
and the possibility of trade-offs between performance level, cost, and delivery time.
Benefits of value analysis are also competitive products and services, better communication,
A lower cost, a more efficient team,
and individual and organizational development.
and finally, better project control. In conclusion, we'd like to tell you that we spoke about value, function,
Function analysis, function tree, cost,
measurement of value, and the job plan. We showed you various examples. We hope you have learned a lot about the value methodologies. Please try VM and let us know how successful you are. Join Value Analysis Canada or your local value society to remain in contact with practitioners, with value users, and pick up tips and techniques.
The Value University is a great place to start your education. Each time you join a value meeting, you will learn more and become more successful in the management of the value of your products, processes, projects, and services.
It was a pleasure for us to explain what value analysis is. It is used by many organizations and administrations throughout the world.
And you, when will you start using value analysis?
There are different resources. Do not hesitate to contact them.
Thank you at all.
Thank you. Goodbye.